Gotta change that, but that's okay. I'm okay with it. I'm a good person. All right, so talk to me about the description. What is slope? Don't tell me rise over run, okay, because that's a method. What's a description that you have of slope? Description of slope. What do you got?
A constant rate of change.
Okay, so it's the rate of change of what? Of a line, yep. Okay, so it's the rate of change of a line, and you said, Jenna, that it's constant, right? Yep. Okay. Okay, and it's always constant, okay, for that particular line. Not for every single line, but it's constant for the individual line. Did anybody come up with a different description of slope? Lots of rates of change, lots of rates of change. Anybody else come up with one? The one that I came up with before? It's the steepness. Or some people call it the pitch of a line. So it's how steep the line is. Methods. Everybody's got one, right? If you were paying attention before, everybody's got one method. What is it? Rise over run. Okay? So the slope, M, the symbol for slope, by the way, is M. Anybody know why it's M? But why is it M? Yeah, that's my question. Anybody know why it's M? No?
Isn't that like the starting number?
Nope. Nope. It was a French guy that came up with it. Okay? And he was walking through his village, and there were different hills. He lived in a hilly region of France. And the hills each had a different steepness, and as he's walking through. And in France, or in the French language, to climb is monter. M-O-N-T-E-R. Okay? This is, by the way, this is 6 years of French right here that I took in college and high school. That's what I come through. 1 day a year. Okay? Monter. Okay? And so it's M. Yep. So that's why. Okay? So that's equal to the rise over the run. Okay? Another way to find slope of a line. Another way. Let him do it. He said it before. Colin said it before. And what am I looking for? Bam. Yep, exactly. Yep. We can have the equation. If we have the equation, y equals mx plus b, we're looking for that m. That's the slope. Okay? That's the slope of the line. So if we have the equation, we have the slope. Even if the equation's not written in y equals mx plus b form, we can manipulate it, mathematically move some stuff around to figure out what it is. Okay? To figure out what the slope is. Okay? What was your next one?
y2 minus y1 over x2 minus x1.
Okay? Yep. So the change in y's over the change in x's is the next one. Okay? So the slope here is the change in y's. That's the rise, because remember on a two-dimensional Cartesian coordinate, y is up and down. So if we say rise over run, that's y. So we subtract the y's, and then x, the run, is the horizontal. So it's delta y over delta x or y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. Now, if you don't like that order, you can switch it. Y sub 1 minus y sub 2, x sub 1 minus x sub 2. And we get those from 2 points. Now you got to have 2 points in order to make a line. So the x and the y part of each point, as long as vertically the same point is lined up, you're okay. And you can't crisscross your x's and your y's. Okay, so those are the 3 methods that we have for coming up with a slope. Okay, so there are 4 different types of slopes out there in this world. Okay, there are positive slopes, there are negative slopes, there are zero slopes, and there are undefined slopes. Okay? So, let me give you an example of a positive slope. M equals 17, or M equals 3/7. Those are both positive numbers. Those are both positive slopes. Yes? Okay. So a positive sloped line looks like what? Give me the description. It'd probably be easier for you to give me the description than it would be to tell me what it looks like.
Slanted up.
Slanted up and
Goes into the positive origin.
there is only one origin. It's at the middle.
Okay, but the section.
Not necessarily.
Quadrant.
Well, so it goes up and
Across.
up
Sideways.
and right. Okay? So the description is it goes up and to the right. But because lines go in both directions, it also goes,
Up to the left.
nope,
Down and
down and to the left. Okay? Right? Because if it's going up and to the right, because it's going in the it goes the same oppositely. It goes, yep, we gotta go opposites of it. Okay? Give me an example of a negative slope.
M equals -40.
Negative 40. M equals negative 40. Or M equals, make it fractionalized this time.
-25/70.
Oh, no, that was reducible. Let's go negative 25/7.
Okay.
Then it's not reducible. I'm always about reducing my fractions. Okay? Like it? Love it? Description of a negative sloped line. Description of a negative sloped line. If a positive sloped line goes up and to the right,
Up and to the left.
up and to the left it would go. Or,
Down to the right.
oops, I started writing the N before I wrote the D and the O.
How did you draw that?
Seriously, pulling that.
What did I do?
Nothing.
Okay.
She's just throwing shade.
Throwing shade at me? It happens. Luckily, I have such a bright, sunny ray of sunshine in my life that I have no shade.
What's happening? It's cloudy today.
It's cloudy today? Okay. All right. So 0 is 0, right?
Yeah.
Okay. Or we could write this as 0 over any number. But when we give it as 0. But it may look like in our calculations, it may look like 0 over 15. we say that slope is equal to 0. Okay? So now let's talk rise over run based off of that last one. My rise is 0, but my run is whatever number I want it to be. So what kind of a line is that?
Straight.
All lines are straight, yep. Horizontal is what I'm looking for, yep. It's a horizontal line. Okay? So it goes left and right.
Sorry.
Okay? So it's horizontal. Okay? Undefined. How do I get an undefined number in math?
I don't know, but I guess it's m over 0.
Okay, so can I divide by 0?
No.
No, I can't divide by 0. This is black now.
Kill a cat,
So
though.
this is going to be some number here divided by 0. And we're going to call that undefined because we can't do it. Okay? So now let's think rise over run again. Okay? I can rise whatever I want, but I can't run left and right. So what kind of lines are those?
Vertical?
Vertical lines. Yep. Ups and downs. I think it's AL. Not a good speller. Best invention of my life, spell check. Okay. What I would like you to do now is I would like you to, first off, I want you to find the slope of these 4 lines. Now, when I say find the slope, that means I want m equals some number. Okay? Or m equals undefined. That's my 2 choices. Okay? Then, on top of that, I want you to tell me if that particular line rises or falls to the right, is horizontal or is vertical. Okay? Go for it. Alright, so my first one is going to be y minus y over x minus x. So that becomes positive 7 over negative 8. So I get a slope here of negative 7/8. Because the slope is negative, that to me says that as we go to the right, that line is going to fall. Agree? Okay. Second one here, the slope is going to be y minus y over x minus x. That's going to be 0 over 15, which then, so that slope is 0. Because the slope is 0, that is horizontal. Yes? Third one. Y minus y over x minus x. That is negative 6 over 0. Can't divide by 0, so my slope is undefined. And that is a vertical line. Y minus y over x minus x. So that gives me 6 over 2/4, right? 3/4 minus 1/4 is 2/4. 2/4 simplifies down to be 1/2. Now, mathematically wise, could I leave it like that? 6/1/2. Mathematically speaking. That looks ridiculous, exactly. We can't have fractions in fractions. That's just goofy. Okay? What now? But we can't have decimals in fractions either. Fractions are integers over integers. Okay? So we have to do a little bit more math. Dividing by a fraction, we think back to 4th or 5th grade, and that's really 6/1 times the reciprocal of the bottom, which is 2/1. So the slope here becomes 12. And that, because it's positive, rises to the right. Questions on any of those four? Okay.
Are there any more like the last one?
Yes, we are not scared of fractions in this class.
You're not scared.
Okay. No, we are not. That's the mindset you have to have. I'm not scared of fractions. They're just numbers. Okay? Okay? No different. Okay? All right? That's the mindset you got to have. Can't be scared of them. Got to take them on. Okay? So, what I would like you and a shoulder partner to do now is I would like you to come up with 4 things. First off, I want you to come up with a description of parallel lines. Then I want you to talk to me about parallel slopes and what those look like. Then I want you to do the same for perpendicular. Come up with a description of perpendicular lines and how perpendicular slopes are related. Okay? Give you a couple of minutes to do that. Give me a description of parallel lines. Description of parallel lines.
Both lines cannot be touched.
So lines that don't touch. Okay, so they never cross, they never intersect. Okay? Real world bestest example of parallel lines. Train tracks. Yep, train tracks. Bestest example of parallel lines. Okay, those 2 individual tracks will never cross because I wouldn't want to be on that train if they did. Okay? Alright? So, slopes of parallel lines. Talk to me about the slopes of parallel lines then. What do we know about the slopes of parallel lines? They have to be exactly the same. Because if one line is rising and running, right, rise over running at a certain rate, and this other line has to be rising and running at the exact same rate, otherwise they would cross at some point in time. So the slopes of parallel lines are equal. Okay? Slopes of parallel lines are equal. Okay? Talk to me about perpendicular. What do we know about perpendicular lines? What? In general, talk to me about the description of parallel lines, or excuse me, of perpendicular lines. I went parallel, okay. I don't know what this is.
It's a description.
They intersect each other.
How do they intersect each other? Okay, we can't just say that they intersect each other because those 2 lines intersect each other, right?
Yeah, and then
These 2 lines intersect each other. Okay? So we can't just say that they intersect each other.
They form a 90-degree angle.
So they're perpendicular because they intersect each other at a 90-degree angle, at a right angle. Yep, that's what we can say here. So perpendicular lines intersect at a right angle. Okay? Dietz, now talk to me about the slopes of perpendicular lines. So one's got to be positive and one's got to be negative, right? Okay? But these lines, you know, so we've got to have something a little bit more than just opposite. What do we call flipped numbers here in math? Reciprocals. Yep. So perpendicular lines, the slopes are, whoops, tap the brakes. Tap at the brakes. This one, that one, that one, this one, that one, there, delete, are opposite reciprocals. So perpendicular lines are opposite reciprocals. Okay? Now, what does it mean to be an opposite reciprocal? Well, if my first slope is A over B, then my opposite reciprocal slope would be what? That's just reciprocal. Negative B over A. Yep. Okay. Alright, so that is what it means. So we flip, not only do we flip the fraction or flip the number, but we also have to make it negative at the same time. Okay? So, my question to you is, this is on the back side now, my question to you is, line number 1 goes through those 2 points, line number 2 goes through those 2 points. I would like to know if those 2 lines are parallel, perpendicular, or neither. So what I have to do then is I have to find the slope of both of those lines. So the slope of line number 1 is going to be y minus y over x minus x. Negative 1 minus a negative 2 is negative 1 plus 2, which is positive 1. 5 minus 6 is negative 1. So that gives me a slope of negative 1. Do we agree there? Okay. Line number 2, so my second slope then would be y minus y over x minus x, which is going to be 3 minus 8 is negative 5. Negative 2 minus 4 is negative 6. Negative 5 divided by negative 6 is positive 5, 6. Okay? So, are those lines parallel? Parallelness, yes? No?
No.
Why not? Slopes are not the same. Boom, not parallel. Okay? Perpendicular. Are those lines perpendicular? Why not? They're opposites, correct? One's positive, one's negative, but they're not reciprocals. Okay? So if it's not parallel, which we said it wasn't parallel because they weren't the same, if it's not perpendicular because they're not opposite reciprocals, then my only other choice is those are neither lines. So they just intersect at some point. Okay? And some angle. Okay? What I would like you to do now is I would like you to do that second example. Are those lines parallel, perpendicular, or neither? First slope is y minus y over x minus x. So that is negative 1 over negative 9, which is positive 1/9. Agree? Love it. Second slope is y minus y over x minus x, which is negative 9 over positive 1, or just negative 9. Parallel. Yes or no? Why not? Different slopes. They're not the same. Okay? Parallel slopes have to be exactly the same. Those are not exactly the same. Perpendicular. Why, Colin? Okay, because the reciprocal of 1/9 is 9, right? And then the opposite of that would be -9, which is what my second slope is. So then those are opposite reciprocals, so they are perpendicular for those two lines. Okay. All right. Next style of problem that you will see a couple of times throughout the year. Okay. Find the value of k so that the line through the given points has the given slope. Okay. So all you basically do is you set up your slope formula. Okay. So my slope is going to equal the y's subtracted over the x's subtracted. Okay. So that's going to be -3 minus 4 over +3 minus k. That's my x's, or excuse me, my y's subtracted over my x's subtracted. And that's going to equal this -2 value. And now you just have to do some math. Okay? So I would here multiply both sides by 3 minus k. So then that gave me, or that gives me, I should say, -2 times 3 minus k. And that's going to equal -3 minus 4, which is -7. Get rid of the fraction if you don't like it. Then we'd have to do a little distribution, which is going to give me -6 plus 2k equals -7. A little adding 6. That gives me 2k equals -1. A little dividing by 2 gives me k is equal to -1/2. Okay? What I'd like you to do now is I would like you to do this other one. This second one. That one. B. That one. Yeah. Yeah. That's the ticket. So I get 4 equals 2k minus 4 all over 3 minus k. Multiply both sides by 3 minus k. So we get 4 times 3 minus k equals 2k minus 4. Do a little distribution. Gives me 12 minus 4k equals 2k minus 4. Add 4k to both sides. At the same time, add 4 to both sides. So that gives me 16 equals 6k. Divide both sides by 6. 16 divided by 6 can't go nice and even, but both can be divided by 2. So I get 8/3 is equal to k. Agree? Okay. Remember, I switched the homework. Okay. Side note, Savannah, I switched the homework. Okay. Okay. Right. Switch the homework. So make sure that that is. So Monday next week, Monday, you're going to have 3 homeworks due. 2-1, that was last night's. If you already got to turn it in. The 2-2, which is this one, and then tomorrow's 2-3. And then remember that tomorrow or next week, Tuesday, you will have a quiz in the MRC. Okay?